Yes. Now let us start it again. We discussed about the problem
Uh,
statement stage. And after this, we discussed about data collection. And now we are into the data cleaning and pre-processing stage. Here, what happens? We remove duplicates and we handle missing values. We convert, we make the data clean. Clean in the sense, clean with respect to the model. Like in this way, the model will be able to understand the data better. That is what data cleaning and pre-processing is all about. So example, filling in missing house prices. Yes, converting 3 BHK to number 3. So here, in Python, we have some data types like int, string, right? So
yes,
this
ma'am.
3 BHK will be, we don't know whether it is a string or a integer or a float or anything. So things will be tough for this to understand. Like anyhow, at the end of the day, it is Python. It is some programming language. So we have to convert into some specific data type. So you know that we already know that text numbers are better than string. Number is better than a string. Text to understand for a model with respect to model. So we'll be converting into number like 3 BHK will be converted into 3. How will we do that? Definitely. If the data set size is 6 like this. Here 6, how do we decide the size of data set? Just because we have 6 samples, it is size, it is the size of it is like 6 samples, that is it. But here we can easily manually do that. Like how to, like here we'll click in Excel sheets. It's very easy. For 500 samples, can we do that? Yes, we can do that if we spend some 1 hour or 2 hours. What if it is 10,000 samples or something like that? We will be able to manually correct it, like deleting this BHK and only keeping to no, right? We'll use some programming. That is
Yes, ma'am.
what the programming is all about, making our making our tasks easy. So we'll learn all that. And fixing typos, like what fixing typos in location names, everything. Like these are like examples what we are going to do in the data cleaning process. Now just we have an example here, like what it is. Concentrate on the yellow regions, yellow cells. Each box can be called as a cell in Excel language. Each box is called a cell, like this thing. So each yellow
Okay.
cell is a mistake in the sense something is wrong with that. We have to clean it. Here we already understood that this date. See here, the data type of this area feature is string because it is the text. Data type of size is number, int, because it is in the integer format. For bedrooms, we don't know what
Yes.
the data type is, so we need to make sure that each feature has only one data type. And that's like a given rule in sense, unofficial rule. So here we have to convert it into int data type. How we are going to do that, let us see. We'll be discussing in some or the other next modules how we are going to do that. So here that needs
Okay.
to be changed. And amenities is okay, like amenities is also fine. Like comma is there, but usually we separate it, but it's okay. We'll be using another methods because it looks quite complicated in the sense parking and lift. But for now, it is a string. Data type is like single data type is there, no, associated with this feature. So it
Yes.
is, uh, I mean, okay. For now, price is like integer. This can be considered as float as well, because if we keep a decimal point, usually price we can't say it, no. So let us assume that float for safer side. And here we got a missing value. What we are going to do that missing value, when we get into that part, we'll be knowing how to deal with this duplicates, how to deal with this missing values, how to change the data type, and all this we are going to discuss. And why this sample is wrong? Because it is a duplicate. We already have one in the first column is
Yeah,
same and
ma'am.
the last column is same. So we have to, usually duplicates will be deleted. That's the only thing. We always remove these duplicates. How do we delete? We have some functions. It is very easy thing to do. It is very fun, this data cleaning thing and stuff, usually because it's the easiest thing in the whole cycle. But it is also
Okay,
very
ma'am.
important, how should I say, this how well we clean the data that much better our model performs. I know this data set we deal while learning seems much easier, but when we get into the real life problems, the real struggle is all about data cleaning, because this data cleaning work will be given to the subordinates like the juniors or the freshers or something, and it will be not this neat, whatever we get during our learning time and stuff, it looks very easy and stuff. Usually when I used to learn the subject, I felt very easy. This data cleaning part was very easy for me. That model training, model deployment, those stages would be very, I mean, comparatively tougher than this. But when I got into that, this data cleaning was completely a nonsense. It was like I know how to do things, but it was a complete, how should I say, uh, time taking task. But it's fun. Once you get into this, it's going to be fun. So after cleaning, this is how it
Okay.
is going to look. See, we got this in this data types are, see, the data type associated with a feature is same, and we missing values we dealt, somehow we removed the duplicate value, and we filled the missing value. How we did it, you will be knowing in the further modules. Not worry about that.
Okay, ma'am.
No, we don't do any things, but you'll get the logic. Only with the logic we'll be able to do the handle the missing values.
Okay.
Now we understood what the problem statement is, data collection and data cleaning. So now data is cleaned. Now our task is to understand the data. In this, the EDA is exploratory data analysis. Data analysis, in the sense, the analysis, the word itself is all about understanding it. I mean, we analyze it, we see it in like different perspectives, and we analyze it. We From different perspectives, you get to understand the data better. This step is all about understanding what we have, so that we'll meet our requirements. I mean, we'll meet our goal, meaning that predicting our house prices. I mean, why should we understand the data first of all? So just suppose that we clean the data, and we just got into the next step, like building, selecting a model, a linear regression or something like that, and we put the data into it. And but we don't know which feature. Maybe we don't know if we remove this size, maybe this amenities feature is not at all important for that price. We don't know, right? If we remove the amenity, the price, I mean, this feature is not at all affecting our output feature. This is what we need to get know, is not at all
Yes, ma'am.
affecting our output feature. So, but in the data set, we included it, and we just ran it, and it's a huge amount of, but if we include unnecessary features or something like that, what will happen? It will cost us time, it will cost us numerous amount of energy, I mean, waste of energy, waste of resources, and waste of time. Understand? So that we need to know which feature is important and which feature is affecting our output. We need to know this. How will we know it? Once we understand the data. See, we have an example here. This is like some charts. Here you'll be knowing every kind of chart. This is a pie chart, and this is some, I don't know, and this is a bar chart. Now there are like great range of charts and everything. Like, this is like data visualization. This thing, when you get all these charts and bars and stuff, this part is called data visualization. Like, you clean the data and you show it, and you explain to the people or whoever, the stakeholders, the word is like, it will be used in the data science field so much. Stakeholder is like the one, our business, our whoever is responsible for this project are called stakeholders. You will be explaining it to them, what is data is speaking. And
Yes.
what is it? Exploring your data to understand patterns, trends, and relationship. Let us see this example. Beauty products sales order analysis. So, number of orders. This is our output. Like, we want to know how many orders are there. Powder, lipstick, foundation, mascara, and robe. I don't know what is it, but just assume that some cosmetic product. And the orders for powder is very high. You can see that from the data. And the lipstick is second highest, and foundation is third highest, like that. From this we can easily say that from the graph, because it is like pictorially represented. the visualization helps us to understand it, right? But if we see this, can we understand it? Can we understand anything like how this bedroom feature is affecting price or something like that? Like before this visualization, data visualization, this bar charts or graphs or something like that, before this will also be in a CSV format. You, with the help of that, this will be constructed. We'll be using some libraries to make this graphs and charts. Okay.
Yes.
Okay, so all you have, maybe I have confused you so much. Now, the exploratory data analysis is the part where we understand the data. Okay,
Okay.
okay. What happens here? Yes, we visualize distributions, correlations, like how two features are related to each other, outliers. Outliers in the sense, remember this word outlier. Outlier is something which is different from other samples. Like outlier, here see everything is like 65, 85, and 60. I mean, even this 15 is also 5 is also okay, comparable. What if it is something like 2 or 3, like 2 rupees or 3 rupees? It is definitely an outlier. I mean, which is not generalized. I mean, not generalized, which does not occur generally. Something which is rare. It might be a correct thing or a wrong thing. I mean, whether it's true or false, leave it aside. We'll deal it with later. But this thing, if we have 2 or 3 here, definitely it is going to disrupt our understanding of data, no? Like, as you, this bar graph right now, everything is in the same. I mean, general for usually understand. Usually, let us fix the range for it. Usually the range would be somewhere between 20 lakhs to 3 crores or something like that. I don't know how this house predicting house prices work, but just assume that this is our range. But if it is greater than that range, it is not going to help us at all. It is just going to confuse our model more. So you
Yes, ma'am.
understood what our outliers are going to do. It is, they are going to make our model confused more. You're going to hear it about much in a much clearer way in the further modules. Do not worry about that. Why
Okay, ma'am.
is it important? Yes, it helps us understand the story behind the data and decide how to proceed. Like knowing which ingredient is salt. Yes, we will be knowing during this step, we will be knowing what each feature is about, how it is going to help our how is going to help our model to predict the price, which is more important, which has the less effect, which has the more effect. Everything will be known here.
Okay, ma'am.
Example is like visualizing how house prices change with the number of bedrooms or distance from the city. Usually, we can play here. We can see that if the bedrooms are 2, definitely this is going to increase. So it has an incremental effect on the bedrooms. The feature bedrooms has an incremental effect on the price. If it is even the size as well, the amenities, maybe depends on the parking lift, it depends other, maybe it can be decremental or it can be incremental, we don't know about it. But how will we know it? By exploratory data analysis. Now we completed 4 steps out of 10. What is first step? Problem statement. And then
Problem
we got
statement.
to, yes, data collection, and we
Okay.
cleaned our data, and then we understood our data. Now feature engineering. Now as we understood our data, now we know what we have. I mean, what our data is telling us. We have that, and we also know that what we want from that data. Like, what do we want from that data? Predicting the house prices. That's all, right? Now we, in this point,
Yeah.
usually this point for smaller projects, like whatever we do in learning stage or something like that, academic projects or anything like that, we don't usually, for the smaller projects, we don't we skip this step. But in real life, this step is always necessary, so I included it. Although it might look like 10 steps, it might be a big thing or something like that, but I wanted to be so specific, that's why I included this here.
Mhm.
Where were we? We have the data, we cleaned it, and we understood the data. And
Yeah.
now we know that what do we want our model to do. Now we are going to make this data such that our model is going to, we are going to make this data in a such a way that it makes things easier for our model to learn better. See, we are going to create a new feature like price per square foot. I mean, we are going to be very precise, like we are going to make it easy for it to understand. And a seller name, assume that there is another column here called area. Beside it, seller name is also there. Definitely it doesn't matter what the seller name is, only the size, bedrooms, that are going to be relevant. So we'll be dropping the feature. That
Okay,
is
ma'am.
also feature engineering, because it is just a waste of a day, memory and stuff, time, memory, everything. So it is waste of thing. So we are going to drop that. That is what example I have written in the example. And now what was the other thing? Price per square foot. I already said it to you. Price per square foot, in the sense we are going to be precise for this area. The price per square feet, like we are going to do math between size and the price. We
Okay.
already did it. So the number got increased. Now, even though we don't have this, even this like 65, I already told you the math between six-digit number is much more complicated, or much, I mean, of course, right now it looks like computer can do, but definitely some milliseconds or seconds, the difference would be there, no? For a
Yes,
sample,
ma'am.
it might be millisecond. Just assume that we have some 1 lakh samples or something like that. Definitely it is going to take some time, isn't it? Based on our
Yes, ma'am.
resources we have or something like that. So we reduce it from the common sense or like the basic knowledge we have. We try to reduce that. That is what feature engineering is all about. Feature engineering is a stage we make our data in a such a way that our model is able to learn it in a easier way. So it is our helping hand, this stage. You understand it like that.
Okay, ma'am.
Okay, then model selection. Now we have our data ready and we know what we are going to do. Now, based on our data and based on what we need, whether we need to predict something or classify something, I mean, detecting spam mails, I mean, that's a classification thing, is whether it is a spam or not, whether like that, it's a classification thing. We'll be choosing an algorithm. Now, the real things. I mean, till now, machine learning is not happening. You know, the data analyst or something like that, right? That role, data analyst role or something like
Yes,
that.
ma'am.
Those people will do the work till here,
Yeah.
or maybe they might get into here. After that, it's the machine learning engineer. I mean, data analysis part, not data analyst. The data analyst is will also be doing all this. But what I wanted to mention is like data analysis part is done with this step. I mean, EDA till EDA, exploratory data analysis. Data analysis is done, and here will be this step is like transition phase, and here we'll get into the real ML. Here, the whole cycle. Here, the ML algorithms, like there will be different algorithms, no? Decision tree, neural networks. Neural networks are like deep learning algorithms. Any kind of,
Yeah.
here we'll select what kind of machine learning algorithm we are going to use to solve the problem. Maybe we
Okay.
might go with 3 or 4 models based on the if we have enough resources, like enough computational power, enough resources, and the data is also quite we can if we have the confidence that we can handle it, then we can handle the data memory, I mean greater memories, then we go for 2 to 3 models. Or else we don't know that. We usually anytime, even the learning stage or even at the real life problems, we usually test it with 3 or 4 machine learning models. Usually models in the sense algorithm. Now
Okay,
we
ma'am.
use that, and we every machine learning model we do in Python. There are some specific libraries like scikit-learn, keras, and pytorch and tensorflow. These two are like deep learning libraries which have this machine learning algorithms. Don't worry, you'll be knowing that in the further models. This further modules, this module is all for what is machine learning lifecycle is all about. This here, what you need to take away, only one point you need to take away from this mod, I mean from this slide, is that model selection will be done in the sixth stage. That is all. Whatever the explanation is, like to make you understand it better, to make you a much more clear view about what is going to happen here. So if you don't understand something so clearly at this point, do not worry, we are going to repeat it again. I mean, we are going to uh, see it in a much more micro level way when we get into that module. Okay,
Okay,
now,
ma'am.
yes, why is it important? Definitely, you'll be knowing why is it important, because some models work better for certain types of data. Yes, there is also that thing. Types of data, I already told you, but as in our third module, for text data, some models are going, some algorithms are going to get better, measure, I mean, do better. For noise, I mean, for image data, some, I mean, for image data, computer vision algorithms, I mean, computer machine learning, computer vision algorithms are going to do better. And like that, for different types of data, there will be some algorithms. An example for house prediction, you might choose linear regression. Linear regression is the first starting step of everyone who is going to start the machine learning thing. Random forest and XGBoost, and these are
Yes,
like
ma'am.
various machine learning algorithms. Do not worry about their names. You understood that in this stage we are going to select a model to work with our data, so that we'll solve a problem. Then what will we do? This is where I want you to concentrate clearly. Now we selected our model and we have our data cleaned, and we know what to do. What do we do? We need to, what should we do? We need to create a model which predicts the house prices. How will it do? Here it is a transition phase again. I mean, transition step again. That's why it is 6.5. Splitting the data set. Data set in the sense we have a data set. How should I? Yes, example I've already given. Please follow this cursor. Can you see it? From
Yes,
1,000
ma'am.
housing records. Housing record. Record is also known as sample. I mean, one row.
Oh,
Just remember the terminology. Different words will be used, but everything means the same. So
okay.
we'll be discussing. I already told you we are going to train our model, then we are going to test it, right?
Yes,
For that,
yes.
we are going to divide our data set. I mean, 800 samples will be used for training and 200 samples will be used for
Test.
our testing. Usually, we do it in a 80%, 20% way. 80, I mean 70 to 80%, and 30 to 20% will be using for testing.
Okay,
That's the general thing. It's like not like fixed. Usually, that gives us better results.
okay, ma'am.
So that's why 80% 20. This is like a example for you. What is it? Dividing the data sets into two parts to train and evaluate. Evaluate in the sense, test the machine learning model. I mean, we are going to put this data set into first 18 records with these 18 I mean 8 sorry 1800 records are going to put into that algorithm. I mean, that are going, those are going to, all these features, whatever it is, all those 800 will be we'll be sending them into the algorithm. We'll, by with this 800, it is going to learn, and we are going to test how good, I mean, how well it learned with this 200. How will be knowing that? How we will be doing that? We'll learn in the further modules. Just understand that this is where data set will be split
Okay, ma'am.
after model selection. Okay.
Okay, ma'am.
Okay. And used to train the model learns patterns and relationships from this data. Yes, in the training data set, typically 70 to 80%, and testing set used to evaluate the model's performance. Performance in the sense how well our model is going to do. Helps check, it helps us to check how well the model works on the unseen data. Yes, only while learning, our model only saw these examples, 800 examples. It didn't, like, it didn't know this 200 examples, right?
Yes, ma'am.
So with this testing set, the whatever the model's performance, the result we got, we understand that okay, it maybe we if we get 80% or 90% of result, just understand that this is an exam for it, how well it is going to do on the unseen real life data, how well it is going to work in the real life. Right now it is still in our project level.
Okay, ma'am.
So how well it is going to do, if it is 80% or 90%, if we get that result like that, then our model is going to perform 90% correct, and 10% there might be some wrongs. So usually we try to make it as high as possible, because that is what really important, no, the error rate in the sense, uh the wrong the accuracy, how should I put into, um, our model needs to learn the things better in a right way, it needs to predict in a right way. If we, so now apart from this 1,000 housing records, if we give some random new unseen in the sense, the model apart from these two, if we give that, it is going to, if in this testing data set we got a result that 90%, okay, 90% in the sense 90% our model is going to guess correct, and 10% it might say wrong too. That is what is all about. Now if
Okay, ma'am.
we give a unseen sample to our model after everything, now if we get a number like 65 lakhs or something like that, the house price or something, then what can we understand, 90% this might be right and 10% it might be wrong. Okay.
Okay. Okay, ma'am.
Okay, splitting the data, you understood why splitting is done, right?
Yes, ma'am.
Okay. Model selection, yes. Feeding the training data set into the, I think this is model building. I think I have written this wrong. Please, I'll correct it tomorrow. Just
Okay,
seventh one is like not model selection, it is model building or training.
okay, ma'am.
Training, you put it like strike that selection and put into training. Okay, I'll note
Okay.
it first of all. Okay. What is it now, in this model training we don't use that testing data set, we are only going to use that training data set. In our example it is 800 records, no, we are only going to use that 800 samples in this training session. What we are going to do, feeding the training data set into the algorithm so it learns patterns.
Okay.
So what it is going to learn, effect on data set, only training data set is going to used during this step. Always remember, in model training we are going to split the data set, and in model training we are going to give the training data set.
Okay.
Okay. After from this 1800 models, it is going to learn how we learned things, I mean the size factor, how we saw in EDA, exploratory data analysis, we understood, no, if we increase the size the price is also going to increase. Yes, we understood that. Now the model is going to learn that pattern. Whatever we learn from visualization, it is going to learn from this in the stage. I mean, that model algorithm is going to learn. I mean, it is going to learn that area, the more area, the higher price. More square feet, the more price. Far location, the lower price. That is how. This is output. So it is going to understand that how these features are going to affect this. I mean, the whole purpose of that algorithm is to, I mean, right now in this project is to predict this, no, the price.
Yes, ma'am.
So that's why it is going to learn all the patterns. How it is going to learn, let us see in the further modules. Right now you just keep in your brain that this is what is going to happen here. Mansa, is this
Okay,
enough
ma'am.
for today, or else can you take it? Nothing is there, like we can, I want us to get here, like I want to complete this machine learning life cycle. I'll repeat it tomorrow also, like the summarizing.
Yeah, ma'am. Yeah, ma'am. It's okay. You can continue.
Okay, in
I
10
can
minutes.
understand it.
Okay, in 10 minutes we'll close this. Okay.
Okay, ma'am.
Okay, now we have come far enough. Like we understood what is problem statement, we collected data, we cleaned it, and we understood the data, and then we made things
Okay.
easier for the model. Then we selected some model, and we splitted the data, and we trained our model too. Now, what is that we are going to do? We are going to test it with that 200 thing. 200, I mean 20% of data set,
Yeah,
evaluating
ma'am.
the model using the testing data set, then tweaking to improve the process performance. If we see, tweaking in the sense, nothing tuning in the sense, if we see our model, like it is, if it is giving above 80%, usually above 70% is considered a success. 70 to 80 is like, okay, your model is going to do good. Above 80, it is like, okay, your model is doing great. If above, if you get 90 or something, then in real life, I'm saying, usually in academics, you always need to get 90s or something, because the data set will be much more less complex than real life.
Yes, ma'am.
Okay. Now, but actually, it depends on the size of the data set too. So usually believe that above 70, it's a good sign. But when we deal with smaller data set and much more cleaner data set, our result needs to be above 90 or something. Now, how we are going to, usually when we write an exam, we know we'll be decided how many by, like, marks. It will be decided by marks. Just like that, we have some evaluation metrics in the sense, some measures to judge how well our model is doing. Okay. So that is what the performance metrics, evaluation metrics or performance metrics, both are same, remember that. Yes, the training data set is used only for evaluation. It remains unchanged and untouched during the training. And we get performance metrics, like all these we'll be discussing. We need to remember what are this. You'll be having lots of formulas for this to remember. You need to remember
Okay.
that formulas to understand how our machine is doing. And based on the test predictions, yes, based on the test predictions, these are like marks of our algorithm in our language. And after this,
Okay, ma'am.
by seeing this numericals, we'll decide we might change some things according to that. If we are getting below 70% or something like that, we'll do some other measures to make it higher. That is what tuning is all about. Okay,
Okay, ma'am.
hyperparameters, I highlight. I changed the thing because you're going to learn it in the further thing. Right now, we can't understand it because we are not in that depth. So for now, just understand that this tuning means if we get something, our performance metrics are low, then we are going to do some measures to make the model learn better. Okay.
Okay, ma'am.
Okay. Ninth one, model deployment. What is it? Making the model available to users via apps, APIs, websites or dashboards or something like that. So, right till this, our model is like ready to be deployed. Deployed in the sense, available to the users. They can use it. Here, who are our users? In the first problem statement, we already know who are our users. Buyers, sellers, real estate agents. So we are making it available for them uh, by deploying our things in the apps or websites or something. In this step, the software development is going to enter, web development, mobile development, app development, something like that. No,
Yes,
that
ma'am.
knowledge is required in this step. Do not worry if you don't have that. Python have some libraries to understand that. Definitely, we are not going to teach web development or something like that, but where you can understand things, still where you need this machine learning course needs, we'll be teaching them. Okay. And what happens,
Okay,
we'll
ma'am.
integrate in the sense, we'll combine, or integrate the model into the system where real users can interact with it. Why is it important? A model is only useful if people can actually use it. So you understand why is it important. Example,
Yeah.
your house price model is now on a real estate site giving instant price predictions. So it is deployed. It is working in real life, real time.
Okay, ma'am.
Okay. 10th one, model monitoring or maintenance, keeping an eye on the model's performance, updating it when needed. Yes, that is what I already told you in the first machine learning, when I was introducing that machine learning life cycle. What happens? We watch for changes in data. The
Yeah.
model which we trained on, the data set which on which our model is trained on, that might be in 2024 or something like that. After 2 years or something like that, the trends might be changed or something. Definitely, no. The 2028 or something, the trends might have changed. We'll be making our model learn that too. That is what maintenance and monitoring is all about. Why is
Yeah.
it important? Data changes. Without updates, your model can go stale. Like, okay, whatever it is, you forget about this. as the data changes, we need to keep updating our model as well to make it relevant. I mean, to make the outputs, whatever a model is going to give, if we want them to be accurate or correct, then we need to keep updating our model. That is all maintenance is all about. Okay, we
Okay.
are done with the machine learning life cycle. It is something. Now let us see that. Now you understood what is all about. Usually this
Problem.
arrow will not be there, but I don't know, like many things, like it is always like that. What happens is, like if something wrong happens, we can always jump like this. I mean, again the problem statement will be,
Start from the beginning.
yeah. So there is, if some problem arises, something like that, something will be done. Or else if in data cleaning we understood that we need some more data, we might not know every information in the problem definition stage, no. If we know
Yeah, ma'am.
here, we are going to get back to the stage one, and then we are going to come again like that. So
Okay.
things are not always in this direction, they might go back and come here. uh, that going back might cost us some time and money if it is a real life project or something like that. What if we got into the stage where we selected the model, but we just realized that our data is not relevant enough, we need some more data, then we need to go to this process. I mean, we need to whoever is responsible for the for that department, we again, the entire team need to I mean, entire team need to go back to the time where they, I mean, there is so much of time waste, there is so much of time waste, and the clients, you know how things work in that. Understood? So
Yeah,
this
ma'am.
is what machine learning life cycle is all about. Okay, we
Oh,
learned too much today, let us have a break now. I mean, tomorrow we are going to continue. Okay.
okay, ma'am. Thank you, ma'am.
Okay, Mansa, thank you.